So now we're going to integrate 1 over x squared minus 6x plus 34. So when you first approach this problem, you might consider, okay, maybe I should try a u substitution. If you're going to try a u substitution, most likely you would let u equal this denominator, this expression in the denominator. So u equals, here, let me just write it down. You would probably try this. U equals x squared, minus 6x plus 34, which means du would be 2x minus 6 times dx. We don't have anything like that to work with in this integral. So I know a lot of the previous videos that I made, we would need something like 2 times dx, and so I would say that's no problem. If you need a constant multiple, think of it like you're multiplying top and bottom by 2, move the reciprocal outside, and that's fine, that works great. When you need more than that, so when you need an expression of x like this, that's not going to work. So that's going to tell you that this u substitution is not going to work in this case. So then, second thought might be, okay, well, I have these integration formulas that I learned about in this section, and I'm probably supposed to use one of those. And when you look over the 3 of them, 2 of them have square roots in them, which we don't have here. And then the third one would probably seem the most likely at that point, which is when you have 1 over an expression of the form a squared plus u squared times du, in which case the antiderivative is 1 over a inverse tangent of u over a plus c. Okay, so that's the only idea maybe that you would have at that point, just considering your options. So you're down to that, just sort of process of elimination. Okay, but this integral it's not in that form. So we need to write this given expression in the form, we want to turn this into some number plus some expression of x squared. Or if you want, I can write this as a number squared. I mean, it doesn't matter. Whatever number we have here, we're just going to take the square root of that. But so we want to put it in this form, a squared plus u squared. The process of taking an expression like this and writing it in that form is called completing the square. And you may remember that from your algebra days, or possibly pre-calculus, I don't know. Okay, so what we need to do is complete the square on this expression right here. And I guess I'll write that down. So we're starting with x squared minus 6x plus 34. If I want to try to put that closer to this form, a squared plus u squared, it's addition, so the order doesn't matter. It doesn't matter if I have the expression of x first or the constant first. But one thing I could do, I'm going to put the x part of this expression in parentheses. So at least now I'm getting closer maybe to having it look like that. Okay, but the catch is that this needs to be a perfect square expression. So we want this to be one expression all squared plus some number. So we want to take this x squared minus 6x. So if you remember completing the square, you add some magic number here that's going to turn this quadratic expression here into a perfect square. But we can't just go adding whatever number we feel like to an expression and then saying, okay, well then this is the same as the original problem. It wouldn't be. So we need to balance it. If we're going to add, let's say 16 right here, then we would need to subtract 16 outside. So I'm going to go ahead and put a minus blank right there to remind myself to balance whatever I do here. Now when you figure out how much to add, this is going to hopefully harken back to your algebra days. You take the coefficient of x right here, so in this case negative 6, divide it by 2, and square it. So this will be negative 3 squared, so we need to add 9. And in order to balance that, I'm going to subtract 9 outside of the parentheses. So notice that if I combine like terms in all this, I would be back to this original expression, x squared minus 6x plus 34, because the plus 9 minus 9 would cancel out. But when I write it this way, if you think about factoring x squared minus 6x plus 9, you'd look for two numbers that multiply to give you positive 9 and add up to negative 6. That would be x minus 3 times x minus 3. Negative 3, negative 3. So that would be x minus 3 squared. And the shortcut to arrive at that right there is it's always going to be x and then half of this coefficient right here. So if I see minus 6, I know automatically it's going to be minus 3 when it's written as a perfect square. 34 minus 9 is 25. So the denominator, the way it's given, is equal to this expression right here. So that means that this original integral, which I guess I'll copy it down here. So the integral of 1 over x squared minus 6x plus 34 dx is equal to the integral of 1 over x minus 3 squared plus 25, which we just found through this process called completing the square, dx. Now this integral is actually in the form that we need, because u now is equal to x minus 3, which means du, in this case, is just 1 times dx. So in this case, du is just directly equal to dx. That's not typically the case, only when the derivative is 1. But so we lucked out here. That's nice and simple. Dx is just straight equal to du. If this is a squared, then a is equal to 5. And so now I just obey the formula here. So this is 1 over a times inverse tangent of u, which is x minus 3, over a, which is 5, plus c. And there's your final answer. So the calculus in this section isn't really the challenging part. It's maybe the algebra, it's remembering how to complete the square, or that previous example video where I had to break it up into 2 separate integrals, and then the Cal1 integral was the harder part of the problem. So that's what you're going to find in this section. I mean, the formulas are very helpful, but there's going to be background information that you need to take your time with. So practicing integrating by substitution, practicing completing the square, things like that. So the algebra skills are what you're probably going to want to focus on building up as you work through this section.